Thank you guys all for coming. This is actually a pretty good turnout. I'm pretty happy about that. This is everything you wanted to know about your terminal. Not really. There's a lot I could talk about, right? I mean, I'm going to be covering some things that could warrant their own 30-minute or 45-minute Thunder talk. So it's going to be pretty interesting. But first, I'm going to start off with a brief story. So this guy is Donald Knuth. They're nested parens. So get it? If you haven't heard of Donald Knuth, he is the author of The Art of Computer Programming, which is just this little thing he started working on in 1968. And it's supposed to be 7 volumes, and so far 3 have come out. The other 4 are a work in progress. Yes, it has been that long. He is also father of the analysis of algorithms. He kind of knows his shit, and he's professor emeritus at Stanford. Pretty cool guy. So, in 1986, a programming journal asked him to write a program. And the program was supposed to read a file of text, determine the n most frequently used words, and print out a sorted list of those words along with their frequencies. I think pretty much everyone can do this in JavaScript now. Not a bad toy problem. So his solution was great. It was awesome. I mean, it was written in Pascal. It used TRIE, T-R-I-E, tree data structure. It was purpose-built for this problem, first of its kind. It was extensively documented. And when they printed this bad boy out in a journal, it was 10 pages long. But there was a plot twist. They asked another guy, Doug McIlroy, to critique his program. And Doug praised, of course, the clarity of this guy's documentation and his implementation. And then he wrote a shell script that produced the same exact output. It was 6 lines long. That's it. This is the shell script that reproduces 10 pages of Donald Knuth's solution. And it is my goal that everyone, by the end of this talk, will be able to understand exactly what this is doing. So, there's going to be a lot of stuff covered. The pacing of this is going to be pretty interesting. At some point, I'm sure everyone will feel lost. If you think I'm making something like way unclear to everyone, please ask me a question. But try to keep it short. Don't tell a personal story. We have a lot of stuff to go through. And yeah, sorry. Let's start with the basics. So, yes. Wait, hold on. Seriously? Okay, go ahead. Yes, I am going to provide some kind of resources. That's like 2 slides from here, so just bear with me for a minute. So just like in JavaScript, a semicolon is your command separator. If you intend to write multiple commands on one line, you got to separate them with a semicolon. Pretty straightforward. A hash symbol is a comment. So I'm going to be showing what the output of some of these commands looks like. So that'll start with a hash. So the first tool that we're going to learn how to use is SSH. And this will just connect you to a remote machine. The -L argument to SSH specifies which user you're going to use. So in this example, you would be logging in as root to mysweetapp.com. You also don't need to log in and open a whole remote shell. You could just run a single command. So if you append the name or IP address or the URL of your machine with a command, that command will just be executed, and you'll be returned right back to the shell where you started. So I actually spun up a virtual machine that, and I don't know how well this is going to work, never tried it before. Everyone is going to log into it and use it to try out some of the commands that I have on here. So now that we've learned how SSH works, hopefully, can everybody go ahead and log into this VM? Your username is student, your password is reactor1 with a capital R. And we'll give you guys like 30 seconds, and then we'll do a quick thumbs check on whether you're all able to get in or not. The syntax is SSH. Well, actually, yeah, that's pretty much what you want to do. Yeah, I guess it's kind of dim. Yeah, what's up? Yeah, it will. Yeah. It's not just going to let you do stuff just because you want to. Yeah. Yes. Question? Question? Yes. No, it's pretty much the same thing. Yeah, I'm just trying to show the range of arguments. All right. That looks good. Is everyone on? Is anyone like having some kind of unrecoverable issue? Yes, go ahead. What's up? Okay, let's do a thumbs check. Thumbs up, I get in. I'm ready to rock. Thumbs down, who are you? Okay. Everyone's got their thumb up. I don't know. Okay, so PWD stands for Print Working Directory. I hope everyone can infer from the name of this command what it does, and I don't need to go too deeply into it. Yes. Okay, are you on the internet? Have you tried turning it on and off again? It's terminal-talk.cloudapp.net. If it can't resolve it, you're probably having some kind of issue with your internet. The username is student. The password is reactor1 with a capital R. Okay, I'm going to move on. So to change a directory, you type cd and then the name of the directory that you want to change into. Pretty trivial. The tilde character, if you didn't know, is a shortcut for your home directory. So if you type tilde or cd tilde slash something, there may actually not be a bin directory. Yeah, don't try that one. But otherwise, tilde is a shortcut for your home directory. Nice. Typing cd is the same without any arguments, just takes you back to your home directory. So it's an easy shortcut. You don't need to type tilde, don't type /home/student. If you just type cd, you're right back home. This is a cool one that some people didn't know. If you go to some crazy path, like /var log messages something, if you just type cd dash, it takes you back to the last directory where you were. Pretty easy way to toggle between directories that way. Which shows you the full path to a command. So if you have, cat is a real command if you're wondering. But if you have, let's say, 3 different versions of Node installed or something to that effect, if you type which node, it'll tell you exactly where the one is that you're going to be executing. Echo prints to the terminal. So if you type echo meow, you should see some output that says meow. It's pretty next level. And of course, the obligatory hello world. So I'm supplying a couple of arguments to echo here. So there's -n, which suppresses the new line at the end. And there's -e, which enables \escape interpretation. So basically what that means is your escape characters, like /n, \t, and other control characters are interpreted if you do this. If you don't supply the E argument to echo, it will not interpret those escape characters. So one thing to note about the way that arguments work in Linux and Unix-like systems, if you're not familiar with this, is that you can combine them. So you don't have to type out echo-n-e. You could just say echo-ne, and it'll combine the arguments that way. By the way, if you're typing this echo-ne hello \n world, you might notice that after you hit enter, and I think I can demonstrate this. Right. The next line starts where world ended. And the reason for that is we're supplying the -n argument to echo, which emits that new line at the end. So if you're ever wondering why we're told to always put a new line at the end of each file, it's because this kind of thing happens. You don't put a new line, and then when you do something with that file, the last line of your output warps with the next prompt. So that's kind of what that's there for. Cat concatenates and outputs the contents of one or more files. So there should be a file in the home directory called hello_world.txt. If you just type cat hello world.txt, it'll output the contents of that file. It's not really what cat is meant for. I see a lot of people do it as kind of like a starting point for chaining commands, which we're going to learn about shortly. The real intent of the cat command is to concatenate multiple files together. So if you have like 2 or 3 text files that you want to put end to end and then do some kind of operation on them, that's what cat would do. There's actually there's another way to use cat that we'll come back to later. But there's something on the internet. It's kind of of a running gag. It's called the Useless Use of Cat Award, uh, and you get the Useless Use of Cat Award by doing that, basically, because there's a simpler way to just output a file than feeding a single file into cat, which we're going to learn about later. So let's try some stuff. This is going to be pretty simple. Just print hello world to the terminal, but use 2 separate echo commands, and have your output not span multiple lines. Give it like 10 more seconds. All right, boom, there it is. This is what your solution should look like. So we're supplying the -n argument to the first echo, so it emits the new line. Use semicolons to separate commands, and then say echo world. Did anybody try an exclamation at the end of world? Anybody at all? No? Okay, good. Well, I'll explain that a little bit later. So the man command is going to be your friend if you are new to the command line and terminal. The man command displays the usage information of a command. So basically, if I type man echo, this is everything that I could ever want to know about echo. And pretty much every command that you could type on a command line has a manual page. You're going to be referencing these a lot. They're super helpful. -K lets you search for keywords. So if you're not exactly sure what the command is that you're looking for, you can do man-k, and that kind of looks like this. Man-k editor. And that gives you this nice list of man pages, everything that has editor in it. So if you wanted to learn about like EX or ed or red, which I didn't even know existed, you could do man and then VI, and then that'll drop you into there. So you might be hit with this man page, and you're like, oh man, like how do I navigate this? I mean, it's kind of obvious here. It tells you press H for help, but that's going to be in any kind of these interactive windows that Linux or Mac OS or anything Unix-based spawns. You're generally able to hit H, and that'll give you a nice key map. So we'll talk about that in just a little bit. There's another utility that's similar to man called info. So it shows you more information, and it's usually on core utilities like shell built-ins and other such very low-level, very basic utilities. So if I do info core utils, this is a whole big manual. And the cool thing about this thing is if you hit H, you kind of learn that it's navigable. So if I want to learn about directory listing, I could just mouse over this asterisk here and hit enter. And within directory listing, I can learn about ls invocation, dir invocation, vdir invocation. So let me just go to ls. And here's the info page for ls, which kind of explains everything. And then it just keeps going through all of the sections. So once again, if you're not sure how to navigate this, just hit H, and it will tell you. So make sure to refer to that later when looking up the documentation for some of these commands. The tricky thing about manual pages that can trip some people up, I know it's tripped me up in the past, is that they have sections. We don't really need to worry too much about these, but basically the sections are laid out like so. The only time you're ever really going to need to know about sections is when something like crontab has multiple manual pages. So crontab is basically a utility for scheduling jobs, and it has a command crontab, and it has a text file, a configuration file crontab, and they're in section like 1 and 5. And if you don't specify the section that you want, in this case it's the file format, then it'll take you to the other one, and you're not going to get the manual page that you wanted. And then man-8, by the way, it just shows you all the sections. So if you don't want to have to worry about hunting down which one it's in, then you could just do that. So by the way, if you do man crontab, this in the upper left where there's a 1 in parentheses, that's the section of this manual page. So this is the crontab command that maintains files. And if I do man5 crontab, that's the section 5 that explains the file format. Right. So yeah, man pages have pages. I know it's a big plot twist. Some of you might be really surprised. Man uses less to paginate output. So less is a pager, which basically means that anytime you have a long file, you can use less to look at it, and it will let you navigate it in a user-friendly way. So I have this nice big authentication log on this server because somebody from China tried like hacking in. It's pretty fun to watch. So if you do less var log auth.log, this will show you the entire huge authentication log. And you can kind of hit space. So let's talk about the most commonly used commands, right? So space goes forward one window. B goes backwards. Those are like the most important. You're typically going back and forward by a window. U and D is up and down, navigates by half a window. Capital G goes to the very last line. Lowercase g goes to the first line. And you can also search, which is pretty awesome. So if I'm in this log and all of these are like user root, right? Like somebody tried to log in as root, but what if I want to find out whether I had any failed logins? So I could just type /Valentine, and that'll search for Valentine, and there you go, invalid user Valentine apparently. And you could hit N to cycle through these. So lowercase n goes to the next instance, and there we go. I've added myself, so now I'm a valid user. And if you like skip over one and you want to go back, you could just hit capital N. So in general, each one of these commands is going to be reversible. So less is used by a lot of utilities that show you kind of paginated output. The name less is pretty interesting. So the first one of these utilities was called more. And more like shows you more information about a file than can fit on the screen. But in more, you like can't go back. You can only go forward. So somebody's like, wait, we could do better. And then they called it less to just like be funny because it's better than more, but they called it less. Yeah. Yeah. Oh, really? It's in the man page? I thought it was spewing like poorly not opposite of more. Yeah, there you go. So shell tricks. These are going to be pretty useful, and these you actually don't typically learn first as you kind of start struggling with the command line. So you guys are like at an unfair advantage. So I'm pretty sure everyone knows about tab completion, but basically if I type /home/v and then hit tab, if there's only one directory that matches that, it'll expand it. So if you ever have a directory with like a 30-character name, please don't let me see anybody type out the whole 30 characters. Just type like your pinky should hurt from how much you're typing tab when you use a shell. Like it should be bad because you don't want to type those long names. And if it's like ambiguous where you want to go. So if I go to like I don't know user L, if you hit tab twice, it'll give you the options, and then you just have to type another letter and then hit tab again, and it'll fill it out for you. This is a really, really good one. So raise your hand if you know how to use Emacs or Vi. Okay, awesome. That's pretty good. That's not a bad cross-section. You guys should be pretty proud of yourself. So if you're on a command line, right? Like I'm not in an editor. I'm just on a command line. You can actually use the same keys that you use for your editor here. So if I hit escape, I am now in command mode, and I can use VI keys. So K goes up in commands, and apparently I didn't hit escape. Oh, I'm sorry. I'm going to cheat really quick. Everyone look away. Okay, there we go. Now I can use K to go up, and I can use J to go down. And, wait for it, you can like use all the other VI navigation key buttons. So you hit W, and it like goes forward by a word. You hit back, it goes back a word. So if you ever type out a command that's like, super huge, I don't know, I'm literally just going to type what I'm saying. You could hit escape, and you could hit B, and like you could go back by a word. You could use all the nice VI keys. So like if I want to change 3 words, I'll just type C3W, and it's just going to remove those 3 words, and I could just type. So this is actually really awesome because a lot of times you string together a command that's like 30 characters long, and then you realize that the second one is like not what you meant it to be. So now you're just mashing the left arrow, and like you get older, you go like make a sandwich, and then the cursor finally comes over to the beginning of the line. Question?
So you just hit escape to activate like the
Yeah, exactly. If you're an Emacs user, you're set. if you're a VI user, you have to type in what I did, and you have to say set-o VI. So basically, there's two modes. There's Emacs mode and there's VI mode. I'm a Vim user, so I like the VI keys. If you're more familiar with the Emacs stuff, it comes preset out of the box to Emacs key bindings. But if you like VI more, then do this. Drop this in your like .bash_ profile, which you should be familiar with from Josh's talk, and it'll always be set this way. So this is super useful. It's like the best way to navigate the command line. Best part is you can also, if you hit escape and like / for VI keys, you can search, which it's like not cooperating with me. I think it's something with my setup, but you can search also. There's another pretty nifty way to search through your command history, and this will work whether you have VI or Emacs keys. So if you hit Control-R, it's going to start an incremental search. So you just need to type like a character, and it'll give you, as you're typing out more characters, it'll give you like the command that you type that has those characters in it. And if I just type C, like obviously I've typed more than one command that starts with a C, you can just keep hitting Control-R, and it'll cycle through all the options. And so as you can see from here, it's not like the command doesn't have to start with a C, it's a fuzzy search. So this is super useful because you can just hit Control-R and type in the name of the command, or if you just remember some words from it, and it'll take you right there. And you would just hit Enter to execute it again. Cool. So these are pretty interesting. So a lot of times you're typing a command that has like a bunch of arguments, and then you realize that you actually intended to run a completely different command. And you need to have a way to reference those arguments because they're like a huge file name or something. So these characters will help you extract those out of the previous command. So let me try to make this a little bit easier to see. Right. So if I type echo 1, 2, 3, right, it's just gonna echo 1, 2, 3. So if I wanted to refer to all the arguments of the previous commands, I could just say echo bang asterisk. And it's going to pull the 1, 2, 3 out of the previous command, and it's going to append it to this command. So I could have done anything, actually. I could do ls or like any other command, and then it's going to say it can't access, it can't find those files because they don't exist. Similarly, the bang $sign is the last argument of the previous command, and then the bang caret is the first argument. Well, I would have to rerun this. Echo 1, 2, 3. And then echo bang caret. That gets you 1. So these are super useful because you don't have to retype all of your arguments. Brace expansion is a really fun one. So if you have some really long file name and you want to copy it to like the same exact thing, but with like a .back or something for backup, you can actually use a bash syntax to make that a lot easier for you. So basically, the way the brace expansion works is you type a number of things separated by commas within curly braces, and bash will go ahead and expand out all those possibilities for you. So I've just solved rock, paper, scissors. Yeah, you literally just type RPS within braces, and if you chain those, then bash will just expand all of them out. Well, I didn't think that was going to be that mind-blowing. I'm pretty happy about that outcome. Right, so the way that this is actually applicable is, let's say you have like some really long file name, and it's got like a gnarly extension like tar.gz, and you want to just rename it to like a .back. You could just put a curly brace, put a comma, and then .back, and close your curly brace. And let me make this a little bit clearer. Right, so that's the command that you would run, and you hit enter, and magic happens, and you get this. So basically the way that it works is, it will, for each parameter within your curly braces, it'll append 1 to whatever else you have, and then it'll just keep going. So basically, I'm not supplying anything for the first argument within the curly braces, so it doesn't append anything to my file name, so it's just a blank. And then I'm supplying a .back. So then it takes the whole file name again and applies a .back. So if you replace MV with CP there, then it would just copy that file to a backup. Sorry? Oh yeah, you just reverse the syntax. So you just say dot back first, and then you just put a comma. Um, I really hope I'm right about this. Yeah, there you go. And you could do this with multiple things. History substitution is pretty cool. So double bang gets you the last command. So sometimes you'll run something that requires root privileges and you're not a privileged user, and now you have to like type sudo and then the whole thing back out again. Don't do that to yourself. You could just say sudo bang bang, and so if I say echo 1 2 3, and then sudo bang bang, it's gonna just prepend sudo to your previous command, and you don't have to retype it. Also, if you want to tack on some other arguments, like let's say I wanted to do this and pipe it into something else, then I would just literally type bang bang and then like do some other stuff here. Bang and then any string gets you the last command that starts with that string. Bang question mark in a string gets you the last command containing that string. And then there's one more like double caret substitution, which is pretty awesome because sometimes you want to run the same thing but slightly different. So like if I say echo 1 2 3, and then I'm like, oh shit, I really meant to say 1 2 4, then I could just type caret 3 caret 4, and it'll echo 1 2 4. So there you go. That's command history substitution. And then finally, there's the fc or fix command. And the way that this works is you type fc and you hit enter, and it pops open your last command in your editor of choice. So if you've like somehow managed to basically write a shell script in just on your command line, and you're like 3 lines deep and you don't know what the hell's going on anymore, and you're like, man, I really wish I was in an editor for this thing, and I should have just probably written a shell script to begin with. Yeah, you could just type fc and it brings up the last command in a real editor that you can do powerful operations with. All right, so those are the shell tricks. Before we do this, are there any questions about anything that I've talked about so far? Oh yeah. Whoa, hold on, buddy. I didn't. Come on, man. I didn't even call on you yet. Sonny, what's up? I use literally everything that I'm showing you. That was like my meter for what I should include in this presentation. Yeah, I've used all of these. They're like once you learn these, they're super useful. Like you should never be retyping long command lines. Yeah. You can. There's an environment variable, which I don't think I talk about environment variables, but you should probably look it up. And basically, it's the $editor environment variable. You set that to your editor of choice, and that's what it opens in. Owen? Save a link to this deck, which I'm going to email you, and refer to it as you do stuff. Jorge? Okay, cool. Any other questions? Yeah. That's a really good question, actually. I think I pretty much just started using the command line because I had to for work, and I've always wanted to learn Linux. And then every once in a while, I'm like, there's got to be a better way to do this. And you could just like Google bash one-liners or like cool Linux tricks, and just spend like 10 minutes a day, and you just learn one at a time. And eventually you integrate these into your workflow. So there's a couple different stages. Like there are things that I'm purposely not showing you. So history substitution, just for example, has all these crazy modifiers. Like you can say bang bang colon s/something/something/g, or you could do like -3 left curly brace :5, and that like does something apparently. You're never going to use those in real life. They're too complicated. It's easier to just retype the command. But simple ones like these, you just kind of pick up over time. All right, guys, I'm going to move on. Got a lot to go through. It's going to be a good night. All right, working with files. ls just lists the files in the current directory. So if you're like in your home, or which I'm not in because I'm not a student, ls. Wow, you guys went to town on this. This is awesome. So those are all the files in that directory. ls-AL. So capital A shows you all the files that begin with a dot. In Linux, Unix-like systems, files that begin with a dot are not normally shown. They're meant to be hidden. So capital A lets you see those hidden files. So any home directory should, by default, have a bunch of these. So this one has like .bash underscore history, .bash underscore logout. You don't usually see those. And the L just gives you that long listing. I'm assuming that some of these are really funny, and that's why you guys are laughing. Kittens.txt. Lols. Kind of remake chatterbox.txt. Impressive. LSLHT. -H is super helpful. It shows you actual human readable sizes and not these like, well, 4096 is pretty easy, but once you get into the realm of like 782933, like quick, what is that? I don't know. I have no idea. So if you type LSLHT, it shows you human readable sizes. So like 765 kilobytes is a lot easier to understand, especially when you get into the larger file sizes. The -1 shows you the output in a single column, which comes in useful if you want to do something else with that output. And the -D shows you information about a directory itself rather than their contents. So normally, if I do lsl/home/student, it's going to show me all the contents. But what if like I want to find out what the permissions are or whatever on that directory itself? I could just add a D to this, and then bam, it shows you the directory itself rather than the contents. That's what D does. And then -R gives you a recursive listing of each subdirectory. It's not too useful, but sometimes you just want to get an idea of how many files are in each level of the tree down. So you would do something like that. Yes? I could have used. No, you can't. You can't. Like lowercase r in ls actually sorts. It reverses the sort order. So arguments and commands in Linux are case sensitive. So if I'm using capital R, it's because a capital R is a recursive listing, and lowercase r is something else. So if you actually, like, let's look at the man page. Maybe I'm wrong. So here's the man page. If I do /-l, that searches, or I'm sorry, R, not L. So there you go, right there at the very top. Lowercase r reverse order while sorting. Uppercase R lists subdirectories recursively. So they are different, and you do have to preserve the case. Oh yeah. If you use a lowercase a, the difference is, okay, I see now why you asked that question. If you use a lowercase a, then basically it shows you that like 1 dot and 2 dot files, which 1 dot is just the directory that you're in, and 2 dots is just one level up. You don't usually want to do those. Like if you're running some kind of command that iterates over the contents of a directory, you don't want to perform that action on those. So capital A just excludes that. Cool. Moving on. mkdir, make a directory that creates a new directory. So when you actually, like if you're following along with this, please use your actual first name and last name because we're going to be deleting stuff too. You don't want to delete somebody else's. And like, don't be a dick and, I don't know, delete the whole home directory or something just because everyone's using the same username. Like, that's just not cool. So if you supply the -p to mkdir, it creates your parent directories as needed. So what that means is, like, if you were to run this command without the -p, it would refuse to do this if first doesn't exist already. But with -p, you could put like 5 directories in one command, and it'll just make the whole tree all the way down. It's actually a pretty useful alias to have. Like, I don't think there's ever a reason why you would not want to do this. And touch just creates a new blank file if it doesn't exist already. If a file does exist already, all it does is it just updates the access time of that file. So this would create a test file with your last name. MV moves files or directories. So if you created the command with your first name and last name in the previous step, this will actually just rename it. So there's no rename command. Move is rename basically. cp-a. So cp normally only operates on files. If you give it a directory without the -a, it'll puke and it'll complain. If you give it the -a argument, it'll move the whole directory and all of its contents. It's typically what you want to do. Finally, rm removes just a file, a test file. rm is not reversible. It's gonna be pretty painful or probably expensive if you delete something that you shouldn't. rm-rf is probably like the worst thing that you can type. Be triple sure that you actually want to do whatever it is that you want to do. So you can use wildcards that like expand to every file name in a directory, and star is one such wildcard. It'll just list all the files. If you type rmrf star, and so just a quick story. I used to be a system administrator working for the Army, and I managed an environment that ran the financial systems for like an entire military installation. And I was like, I was on a hypervisor, which was running like 30 virtual machines, and I wanted to remove a directory, so I typed rmrf star, except I was in the root directory, and yeah, it's really fun just watching the operating system kind of like try to struggle as all of its core binaries are wiped away. Um, that was a really good time. Yeah, so everything went down, and I had to rebuild the box. I had to like sprint to the data center. It was really bad. So now I almost never do this, and when I do, I'm like triple make sure that I actually want to do the thing that I'm typing. Okay, so using some of the commands that I've showed you, cp, mv, rm, go ahead and remove all the crap that you created, and just make a new directory with your first name and last initial. And then within that directory, just create an empty file named test. And actually, I just want to get a quick gauge on the room. So there's a lot of stuff to cover, and like the cp, mv, rm commands you might already be familiar with. So if this exercise is useful to you, thumb up. If it's not at all, thumb down. Please be honest. All thumbs. Is this exercise useful to you? Okay, kind of mixed. We'll give it another 30 seconds. So basically, you would just rmrf whatever directories that you have in here. Cool, awesome, this is great. So I would rmrf not you, for example. Oh, look at that, that's cute. Okay, so that's gone. And then if I wanted to make one for me, then I would just say Valentine B. And then, really, I'm just getting these permission errors because I'm not a student. Yeah, right? See, it's not, sometimes you forget. And then in there, you just cd into there, and then, you could just like touch test. Yeah, I can't touch test. That's interesting. Sudo bang bang. Okay, wow. All right, so this is not working for some reason. Okay. Yeah, usually, I mean, some of these things can be implementation specific. That's really weird. I have definitely used touch before to create empty files. Oh, somebody deleted the directory? Moving on. You guys are jerks. Man, tough crowd. All right. All right, screw that. Moving on. Well, this exercise would be awesome if those directories were still there. But basically, ln just creates a shortcut, right? So the -s is for symbolic link. You should generally always create symbolic links. So the difference is a symbolic link is a reference to a file. So if you use Windows, think Windows shortcut. A hard link is basically another reference to the actual physical hard drive location where that data is stored. So if you make a hard link to a file, it basically is the same file for all intents and purposes, except it doesn't take up that storage again. So if you remove the original file, the new hard link still stays in place. But if you create a soft link or a symlink and you remove the original file, nothing is there anymore. So you generally don't want to be making hard links. They're pretty low level. Like Windows, I'm sure, doesn't even give you that ability, like in the GUI. So you should generally try to stay away from those. Yeah, create symlinks unless you specifically need a hard link. So one application of this is like if your Sublime text is buried like 50 folders deep in your applications folder or something, you can actually just create an alias to it in your like /bin or somewhere that's on your path, and then that will just be executed when you type the command, and the shortcut will take you to wherever the target of the symlink is. Find is a super, super powerful command. We're going to have a lot of fun with it. So if you type this, it will show you all the .bash whatever files in the home directory. And it works recursively. And it has a number of fun options. So the general syntax is find, then your starting point, and then some expression, depending on what you want to search for. So just to be clear, find doesn't search the contents of the files. It just lets you find files themselves. So the -name specifies the file name. You can use wildcards, but use single quotes. You must protect the wildcards from being expanded. What's up, Derek? I'm not sure. If you're doing that, I promise I have ways to find out, and I will embarrass you. So please don't do that. Cool. Um, all right, but come on, like, are we five? Who is responsible for this? All right, cool. Please stop. Um, find that dot dash name dot text would show you all the text files if any were there anymore. So now let's talk about some other things you could do with find. So typef searches for files, and once again, if you're like, oh man, these arguments are so intimidating, just go look in the man page. They're all described there. Dash user student finds the student user, and then you can also filter your files based on a number of other things, like the modification time. So what this command would actually do is it would find any file, not a symlink or a directory, that's owned by student that was modified less than 5 minutes ago with a size of less than 10 kilobytes. So for these arguments, like the size and the modification time, you can actually supply 3 different prefixes. So if you say mmin minus 5, that's less than 5 minutes ago. Plus 5 would have been more than 5 minutes ago. And just 5 would have been exactly 5 minutes ago. And that works with any numeric prefix for find. So just know that you can prefix those with minus or plus. You can also use regex, which I wouldn't recommend because they're really weird with find. You use like the Emacs style regex, so you have to escape all the special characters. But basically, you can also use logical operators like and, or not, but just supplying them as another argument to find. So this command would actually find anything that is not a file or that has an extension of text or temp in the home directory. But wait, there's more. So you're probably like, cool, so I can find all these files, but what can I actually do with them? Fun fact, Fun has a thing called exec, and basically that will do anything you want. Instead of this ls-l, you could type any command, and the curly braces are where the file name will be substituted into the command, and you have to terminate it with an escaped semicolon. So basically, what this command would do is it would find any file and it would just do a long form listing. But you could do anything that you want there. You could move them, you could rename them, you could do any command that you can think of, you could put under an exec. So find can get really fun like this. So basically, that would look in the current directory, which is dot, at a maximum depth of 1, meaning no subdirectories would be traversed. Type F, it would be named something.tar.gz, and it would do is it would execute this fun command, tar_xvzf, which just extracts an archive. And then it would give it your file name, and then it terminates with an escape semicolon. Interesting thing to note here is I've broken up this command over 2 lines. So just a naked backslash at the end of a line is like a line continuation. So you could just type backslash and then hit enter, and it'll let you continue the line. Awesome. Any questions? Yeah. No, this is just for like presentational purposes, or if your terminal window is weird and it like cuts off for you at some point, you could just always do this. But you can also just keep typing. Like in this terminal, I could just keep typing and it'll just warp onto the next line. So you never really have to do that when you're executing commands. It's strictly for presentation. Awesome. Let's talk about job control. All right, so if you guys try this, it's not gonna work, because essentially everyone's logged in as the same user, and you're all just going to sleep for a minute and a half a bunch of times. But I've seen a lot of people do this, and essentially what the scenario that I'm describing is you open Chrome or something from the command line, and then Chrome opens and it pops up a graphical window, and then it just kind of hangs on to the terminal, and it spits out its logging information or whatever. And then what do? You open a new tab, and you're like, all right, forget about that window now. You don't need to do that. You just put an ampersand after any command. It'll be placed in the background. So you could just keep doing stuff in a terminal, and I'm just going to demo this. So if I just do sleep 100, like I'm stuck, it's just waiting. But if I do sleep 100 and then an ampersand, boom, it's in the background now. And then FG will just take any backgrounded job and bring it into the foreground. So there it is. There's that sleep 100 again, and then Control C, of course, kills any command. So if you type jobs, that's a listing of all of the jobs. So once again, if I do this and I type jobs, there it is. There's that sleep. And then if I want to bring it back into the foreground, I could do like just FG, or I could do FG %1, and the 1 refers to the number in the brackets, and the plus sign indicates which one will be acted upon if you don't supply any arguments. So boom, it's in the foreground again. I could just kill it. Cool. What happens if you type a command and you forget the ampersand? Like, do you then have to open a new tab again? No, you don't. You just actually hit Control Z, and that totally suspends the job, and then you just type BG to send it back to the background again. So if I do sleep 100 and I'm like, oh shit, I forgot to type the ampersand, I could do Control Z, it stopped, I type BG, boom, it's running again in the background. Please do this for graphical applications that have like stolen a terminal window from you, and you never have to open a new tab, basically. Okay, I talked about that. PS shows a list of running processes. Typically, if you just run PS, it'll just show you the processes that are owned by your user. PS-EF selects every process that's running in a system. So it's just a long list of what's running, which looks like that. So there's a bunch of students, there's a bunch of roots, just some other stuff. Okay, awesome. And then if you, man, I'm gonna regret showing you guys this with some of the people in the room. So if you type kill and then a process ID, which is what's output in the second column, then you can kill a process. So basically, you would only be able to like kill other people's terminal connections. You wouldn't be able to bring the system down because you're not root. But if I like did the sleep 100 and send it into the background, that number down there where it says 23875, I hope everyone can see that. There you go. That is the process identifier. So I could do kill 23875, and it's going to terminate that job. Anytime you have a long-running process, you could just do that if it's like stuck or something, and that would kill it. Yeah, what's up?
So if it's in the background, why does it not finish running after 100 seconds?
Oh, it would. I'm just showing the scenario in which it doesn't finish running and it gets stuck or something. All right, cool. We're almost up to the good stuff, you guys. Bear with me. Yeah, this is just a warm-up. Don't worry. Kill -9. Don't do this. You're taking a sledgehammer to like a thumbtack if you kill -9 anything. The reason for that is when you exit a process in Linux, it does all this awesome cleanup stuff in the background because the people who wrote it are really smart. So it like closes down sockets, it does garbage collection, all that other good stuff. If you kill -9 anything, you're not giving it a chance to do any of that shit. You're just like die. And it's dead. And then you're going to have all these leftover things in your system. If you do this repeatedly, you're probably going to run out of memory or, I don't know, something bad. Bad practice, don't do it. It's an important cleanup task. pgrep and pkill are two other things that I want to show you. Instead of having to know that process identifier, you just do pgrep, and that'll like just give you the identifier for anything named bash. And if you type pkill, great. If you type pkill and then bash, it would just kill anything that has bash in it. Do I hear somebody typing that like as we speak? That would be great. Awesome. So there are a number of times when you want to search a file for stuff, right? So there's this awesome boot log that's on the system, and if you search for IPv4, you basically get the IP address of the system. So the -I makes the search case insensitive, and I think I'd like to show that. IPv4 var log boot.log. Boom, there it is, IPv4 address. If you didn't supply the -I, then basically, whoops, it would not match, right? Yeah, because it's case sensitive by default. Almost everything is case sensitive by default. So if you want something to be case insensitive, you got to say -I. -V inverts your search. So instead of showing you things that match, it shows you things that don't match. If there's like a configuration file and it's got a bunch of comments in it and you just want to get to the good stuff, you do grep -v pound, and that'll show you anything that's not commented out. These things are going to get pretty fun. So in this case, we're using a non-case sensitive search. We're inverting it, and we're supplying the capital E, which lets you use regular expressions. Another synonym for this is egrep, which I think I show on the next page. Somewhere in here. Yeah, okay, all the way at the end there. Talk about that in a second. C prints lines of context. So if you execute that command, what you'll see is the line on which the IP address was found, and then 4 lines above and 4 lines below it. So a lot of times you're searching for something in a log file and you find it, and then you're like, oh shit, what I really need to know is what's right before it, and you just don't. So you would use the capital C for context for something like that. -L, in case you're searching multiple file names and not just one, it'll just print you the file names that have that text instead of the lines in those files that contain it. And now this is getting really fun. So -O only prints the matching part. So if you actually execute this command and somebody hasn't like deleted this file or something, does anybody want to guess what this regex matches? Any regex wizards in the house? Yeah, who said that? Yeah, you got it, buddy. Way to go. Awesome. Yeah, this matches an IP address, right? If you don't know regular expressions, it basically is any digit repeated 3 times, then an optional literal dot, and that whole thing is repeated 4 times. So that will print you any IP address from this authentication log. And if you actually go a step beyond and like track them using like an IP tracker or something, you'll see that they're in China because somebody is like literally trying to break into this test VM I spun up yesterday. It's pretty great. Cool. All right, we are up to the good stuff now, officially. So redirection. You've probably all seen something like this. So what this would do is it would just take the string hello world. I hope everyone tries to do this at the same time. That'd be fun. And writes it into a file called hello.txt. Pretty simple, right? But how does that operator actually work? So the greater than sign is a redirection operator. So in Unix systems, any device is basically a file. Everything is treated as a file. And anytime you're in a shell, there are 3 files that are open by default. The files are standard in, which is your keyboard, standard out, which is your screen, and then standard error, which also shows on the screen, so there's no way to visually differentiate the standard error from standard out, but there is a difference because any errors that are command outputs go in a separate stream because you want to separate them from the actual output. The numbers that I'm using to refer to these files are file descriptors. So a file descriptor is basically a pointer to an open file. That's all there is to it. So when you first open the shell, this is by default what your file descriptors look like. So devpts0 is just Linux. It's another file. It's Linux convention for your terminal. And basically, the standard in is being gathered from your terminal, and the standard out and the standard error also are both going to your terminal. So the earlier command that I showed, echo hello world into hello.txt, is basically syntax sugar for saying 1 greater than hello.txt. And what that command does is it takes file descriptor number 1, which is your standard out, and it points it to a file called hello.txt. So now you don't see any output because it just goes into a file. The file descriptors are specific to the invocation of each command. So after a command is run, they're reset again. So you can't just redirect once and expect everything to go in there. So what this would do is it would redirect standard error to hello.txt. But when you use a double redirection operator like this, instead of a single one, it actually appends the existing contents of that file instead of overwriting them. So let's talk about really quickly special devices in Linux. So there's a number of special devices that you can use in tandem with your shell commands that will make your life a little bit easier in a way. So dev null, anything you redirect into there will just be discarded. It's like a black hole, garbage dump, whatever you want to call it. Dev 0 is an infinite length to 0 file. So if you want to the way that I've used dev 0 is for wiping hard drives or partitions. You could just zero out a drive by redirecting from this device into a physical device. It's pretty cool. Dev full simulates a file that's on a full disk. So if you're writing like a script or something and you want to simulate what happens when the disk fills up, you could use dev full for that. If you try to write in there, it'll just give you an error that says you're out of space on the device. And then random and urandom just generate random crap. So that being said, what this command would do is it would take any output and redirect it to dev null. But wait, there's more. So there's this other operator here where you're saying 2 greater than ampersand 1. And what that does is it basically takes standard error and it redirects it to the same place as standard out, which is dev null. So this is what the file descriptor table looks like after this operation. So what we're doing first is we're taking standard out, which is 1, and we're sending it to dev null. And then when you say, if you were to just say like 2 is greater than 1, then it would take standard error and it would write it to a file named 1. In order for you to say that you're referring to a file descriptor instead of an actual physical file, you have to precede it with an ampersand. So that would take 2, which is your standard error, and send it to the same place as 1, which is dev null. Cool? All right. The order matters. There is a wrong way to do it, and it's right there. So if you ever try this, this is the wrong way to do it. This would not work. Basically, what you would do is first you take standard out, or excuse me, standard error, and you send it to the same place as standard out, right? That's what that 2 is greater than ampersand 1. But that place is not dev null. That place is dev PTS 0 because it's being processed from left to right. So then when you say redirect standard out into dev null, you're going to get that. Standard out is going to go to dev null, but it doesn't automatically change standard error. So if you want to do this kind of operation, you basically learn pretty quickly. Like, you don't really need to understand like the in-depth theoretical thing about how this works. Just pretty much the takeaway is you do the second redirection afterwards. And if you try it and the thing happens that you don't want to happen, you're going to know. I talked about that. Cool. So instead of output redirection, you can also have input redirection. So basically, that would take the contents of processes.txt and pipe them into grep. So basically, what that does is it redirects your standard input to now come from a file. So instead of you providing some type of input to this command, it'll just read it out of a file, and it would search it for SSH. In case of grep, it's not that useful, but as you'll see shortly with other commands, this gets pretty awesome. So if you remember, grep-o only matches that part of the word. So the pipe operator, which is a vertical line, it takes the standard out of one command, and it pipes it into the standard in of another. So basically, when you echo spaceship and pipe that into grep-o ship, grep-o will now search just whatever the output of echo was, which in this case was spaceship. This gets really fun with the piping. So the problem with the previous command is that only standard output is redirected. But what if you wanted to also pipe standard error? Pretty easy. You can combine it with another redirection operator. So first you send standard error to the same place as standard out, and then you pipe it into grep file. So if you execute this command, it'll basically match file in the error message of this command. And then finally, T is a cool little utility. Sometimes you want to write things to a file, but you also want to see them on the screen. Just use T. It'll show you on the screen and write the file. It's like a T for your file descriptors. All right, that's pretty much it. There are a bunch of advanced things with this that I didn't cover. There's all kinds of crazy shit like named pipes. You can open, move, and close file descriptors. You can duplicate them. You can do all kinds of things. I'm not going to talk about them, because I could spend an hour just talking about that. And now that we've talked about piping, we can combine all of these single-purpose commands to explore a whole new world of wonderful Unix nirvana. So what if you wanted to take the output of one command, and instead of supplying it as standard input to another, supply it as arguments to another? So for example, what you might want to do is you might want to find some files with find, and then you want to search their contents with grep. You might be tempted to try something like this, right? You say find in the home directory, anything that ends in .text, and then do a case-insensitive search for hello. So that's actually not the right way to do it, because what would happen here is grep would attempt to search the names of the files that find finds, and it would just match those. It would not match their contents. So what you need to do is you need to use another utility called xargs. So now we're kind of getting into like the real Unixy stuff. So what xargs does is it takes a number of things on its standard input, and then it builds up an argument list. So basically in this scenario, find would output like 5 things separated by new lines, and then xargs would take those 5 things and it would just append them to like the end of grep. So let's say find returns 1, 2, 3. Xargs would execute grep I hello in 1, 2, and 3. So that's how you would do that. You typically see this with find and grep, and this is just a quick footnote. I feel obligated to show you guys this because if there are any files that have weird characters in the name, like specifically, you can have all kinds of shit in the name of a file in Linux. You can have like tildes, you could have new lines, like you could have a file name with an enter in the middle of it. So that would really screw up your day if you were trying to use this form. So if you supplied -print0 to find, and then a -0 to xargs, now these two commands use basically a null character instead of a new line for their inter-command communication, if you will, and that will prevent that type of thing. So I have a useful alias on my machine that I really like. So basically, it's an alias called here. And here is this whole command up to right before the grep. So basically, anytime I type here, it grabs all the file names in this command, and then it like waits for me to tell the computer what to do with them. So I could just type here grep stuff, and it'll take every file recursively in the current directory, and it'll search them for the word stuff. Super powerful. You could do whatever you want. Yeah. Oh, actually, I don't have. So you would omit the name part of this. You would just have it find typef print0. So any file. Cool. So now that we know how to do that, we can actually manipulate text using all these Unix commands. So WC just counts the characters, words, or lines in a file. So if you execute this command, wc-l varlog auth-log, it'll basically tell you how many lines are in this authentication log. Head shows you the very beginning of a file. So if you want to know what the first 10 things were in that log, you actually don't have to type head-10 because 10 is the default, but you could type like head-50 or head-100 or head-5, and it'll show you the first that many lines of this file. Head has a complement called tail. Tail shows you the last n lines of a file. But tail does something a little bit different, which you may not expect. If you supply -f to tail, the F stands for follow. And basically, as that file is updated by the system, tail will just show you any new output. So if you have a log file that's being written and things are like happening in real time, you do tail-f, and it'll just show you the updates in that file. So if I do tail-f varlog auth-log, oh, look at that. This is awesome. I was hoping this would happen, guys. So there's actually somebody from like China just hammering at the system right now. Each new line is a failed authentication attempt. So by us watching this log, we could just see somebody like just desperately trying to log into the system. And that's basically your use case for tail-f. It lets you monitor logs in real time. This is in varlog auth.log. Yes, it is more or less standard. Varlog on pretty much any Unix system is going to be the directory for your logs. The name of the file itself might be slightly different. But yeah, that's in varlog is where you're going to find all that good stuff. Each distribution implements it differently. And then, of course, you could filter that now that we know how to pipe things. You could just grep-i failed password. And if you do that, then you're not going to see all this garbage. You're just going to see the good stuff. So I could do bang bang grep-i failed password. Boom. Now, every time something happens, it'll basically print any lines that match it. So the cool thing about this is you could use tail-f, and then you could filter it through any number of commands, and it'll do that processing. But as long as tail-f is supplying more output to any commands that you pipe it into, the whole pipeline works, right? As long as this command is still executing, it'll still do this stuff. And in just a little while, we're going to learn how to like take this and just morph it into something entirely different and just literally only see the information that you care about. This is the first step to doing that. Cut basically removes sections of a file or sections of files that are separated by some delimiter. So in this case, the delimiter that we're using is colon, that's the dash D, and the F specifies which fields to output. So we have this file called etc password, and that contains all the usernames in the system. So if I do cut D colon F1 on etc password, it'll remove everything after the first column, and basically this will just show you all the usernames on the system. You can supply a range of fields to dash F, so these are all valid. The first one is the first one until the end. The second one is the first one through the fourth one, and then you could do like the second one through fourth one. There are ranges. TR is another super useful utility. TR translates characters, so it'll take whatever's in the first set and convert it to whatever's in the second set. So in this command, we're using the input redirection operator, and we are redirecting etc password into TR. And what this would do is it would just take those colons and replace them with spaces. So TR colon space etc password, boom. Now you have spaces instead of colons. This command would take, so TR, if you do man TR, you learn what all of these are, and these are like shortcuts for whole characters of classes. So that would just take anything that's in lowercase and convert it into uppercase. I won't spoil what this would output. It's just hello world and like all uppercase. And then a couple of other useful arguments are dash C. It's like saying not. It's the complement of that set. And dash D would just delete instead of translating. So this would delete anything that is not an alphabetic character. Okay, little exercise for you guys. Replace colons with tabs in etc password and save it as home student first last. I think I'm just going to demo it because I am trying to stay conscious of time. So basically, what we do is just tr colon and then a tab and then get that into etc password, and then we can redirect it into home. I'll save it in my own home valentine valbog.txt, and then if I do cat, and this is another shortcut for like the last argument. Oh, great. Cat home valentine valbog.txt. Yeah, there it is. So we've taken all the colons and we've replaced them with tabs. Pretty sweet. Sort just sorts a file. It's exactly what you would think it would do. Takes a number of arguments and makes it numeric. Otherwise, it would put 101 before 11 because it's doing a string sort and not a number sort. And then the K just tells it which column to sort by if you have multiple columns. Now we can kind of start combining these and getting into the fun stuff. So this would remove spaces from processes.txt. Oh, no, I'm sorry. This would just separate processes.txt by spaces and give you the very first column, and then you can sort them and remove duplicates. So I think processes.txt was just the output of PSEF. So let's do that. Processes.txt. And then we could do cut deep F1 processes sort U. And that's basically a sorted list of all the usernames on this system that are currently running processes. Okay, there's also unique. So you might be like, hey, unique is like the same thing as sort-u, and you would be right, except there's one little difference. Unique-c gives you a count of the duplicates that it removed. So yeah, it's usually faster to use sort.u, but if you want to count duplicate items, then you have to use standalone unique. Boom. This is the script from the beginning of the presentation, right? This is what Doug McIlroy wrote to replace 10 pages of Pascal, written by the father of algorithmic analysis. So now that you know what all these things do, we can really parse out and see what's happening here, right? The dash CS for TR, it takes the complement of that set, and dash S stands for like squeeze. So basically, it would take repeated iterations of anything that's not an alphabetic character and we replace it with a new line. So this will take any file, and anything that's not a letter, it replaces with a new line. Then you pipe that into another TR, and you take your uppercase set of characters and turn them into lowercase characters. Then you sort them. Then you do unique -c. So now by the time that you've gotten here, you have a sorted list of words that have a count, but they're sorted by the words, not by the count. So you pipe them into another sort, and you sort numerically by the count, and you reverse the sort order. And then basically, if you were going to try to run this, then you would just replace this, this whole construct here, this $1, with an actual number. And it would get you that many lines. That's the whole shell script. Cool. All right. Everyone's falling asleep, so there's a little something special that I want to show you first. But yes, I will do that right after. Oh no, what happened? Wait for it. Wait for it. Oh yeah. If you are a Linux guru like myself, you're going to be able to do this. Oh no. What's going to happen? This is an actual real-world demonstration of what happens once you get good at this. This is what you should all aspire to be. Cool. All right, guys. I mean, that's it. That's the end. I have a couple more slides, but it's been a while. So I'd like to take the time to address any questions. Yeah, Brian.
All right, so you know all this crazy bash stuff. Are there any good resources you would point somebody to who wanted to get better at that?
Excellent question. Bash scripting. See, the cool thing about all this stuff is it's been around since like the 1980s. So you could literally just type in what you want to learn about. And this here, the very first result for this, the Advanced Bash Scripting Guide, is like the canonical reference for Bash scripting. So if you want to learn about some like really crazy shit, I mean, I've hit it, like honestly, in this whole like hour and 15-minute presentation, I've basically managed to like scrape the surface of what you can do with Bash. There's a lot of really, really crazy stuff. Subshells, process substitution. Actually, there's a slide for this that I have that I want to show you guys. Let's go over, let's kind of, yeah, there's some scripting stuff. Okay. This is like the beginning of the things that I didn't cover. And my reference for this was like the man page for Bash. Like I typed man bash, and these are all the things in there that I didn't even like really touch on. And that's just Bash. You have to keep in mind that there's like, I don't know, 800 other man pages. So this stuff gets really, really deep. But this Advanced Bash Scripting Guide basically is what you would refer to. So I didn't mention scripting, but Bash is its own programming language, right? There's real control flow. So you can do while loops, you could do for loops, you could do ifs, you could do tests, you could have all these constructs. There's variables, there's arrays, there are data structures. You can write a Bash script that like does real stuff, and it's a real programming language. So when I had to write a shell script for the first time, I basically used this to refer to. So this is how you basically learn. It could be kind of dry. It's more like a reference than anything else. But if you Google like Bash one-liners, that's a really cool resource. Just basically look at one-liners of people doing cool stuff, and then just try to understand what's happening there. Excellent question. Thank you for asking that. Yeah.
So the person from China trying to hack into your thing.
Mm-hmm.
Does that always usually happen to whenever you set up a server? Has they ever gotten in?
No, they can't get in. You actually, Ubuntu is set up so that you can't log in as root. That you have to do like sudo, and that elevates your privilege. You can't directly log in as root. and they're just trying to log in as root, so it's kind of just fun to watch. But yeah, no, seriously, like I've set up. This has been going on for like decades. I mean, I remember setting up an FTP server just to like share some files with friends when I was like 12. And in the access log, there's like people from China that are just randomly like checking your password against like some dictionary list. So yeah, it's pretty normal to see that happening, and you normally don't think twice about security, right? Like some of us are running blogs in a DigitalOcean droplet. I know I am. When you spin up a brand new DigitalOcean droplet, Linux has a firewall that's really powerful. It's called IP tables, and basically it just denies everything by default, and it allows some things. It's not running in a DigitalOcean droplet. When you spin up a brand new DigitalOcean droplet, it takes all of your ports, and they're all exposed to the outside. So you just can't see these log files, but this type of shit is happening with like every port on your system. Like somebody's just constantly hammering at it. That's the bad news, right? The good news is that Linux is really secure out of the box, so it like mostly doesn't matter unless there's some crazy zero-day exploit that they happen to find. But in a real like real-world scenario, so I happen to have the experience of working as a systems administrator for the government. There is a manual called the STIG, stands for Security Technical Implementation Guide. And this thing is a tome about this thick if you were to actually print it out. I don't think anyone has in like the history of the universe. And it basically is just a step-by-step direction for how to harden your operating system. So you have to run like 5,000 commands, and you end up changing the file permissions of like every file in the OS that's a system file. You end up closing down all these ports and all these services, and you end up with a really secure configuration after you do the hardening. But that's for like government grade stuff, right? If you're just running like your blog in a DigitalOcean droplet, probably not that big of a deal. But you should like set up a firewall and just leave open the ports that you're going to use, like SSH and like port 80 for web stuff, and just have it drop everything else by default, and then you can sleep safely. You can sleep tight at home. But like I didn't bother honestly with my blog. The second that I put up anything more important on it than like three posts, I'm gonna like do some hardening on there. Great question. Yeah, Sonny. Yeah, of course. This is on slides.com. I'm too cheap to pay for a premium account, so they're open source. I will make sure that everybody gets a link, and it's a good reference for you guys.